What's up, guys? This is kind of, well, it is definitely less lethal related, but this is the joules per square inch formula, I guess you could call it. So 68 caliber, 50 caliber, what you have to do is you have to turn this number into radius squared times pi. So 68 caliber divided by 2 is 0.34. That's the radius. So this is the first part of the equation. Radius squared of 68 caliber, which is the R number, 0.34 squared, equals 0.1156. So pi is 3.14 and it goes on to infinity. If you have a scientific calculator or a phone that has a scientific calculator mode, you can do 0.1156 times pi, or you could do 0.1156 times 3.14, and you get this number, 0.3631, which is basically this whole equation at 68 caliber. So this is the main number you need to worry about. 50 caliber divided by 2, you get R, 0.25. You have to do R squared with that 0.25. So 0.25 squared equals 0.0625. Okay, so 0.0625 is part of this equation. This is the R squared part. So R squared times pi, which is what you're trying to do right here, equals 0.1963. So these are the main numbers you need to know for 68 caliber and for 50 caliber if you want to convert it to joules per square inch. So I have that right here. 68 caliber equals pi r squared, which equals 0.3631, and it goes down way more decimal points, but I feel like this is good enough. And 0.50 caliber, the pi r squared of that is 0.1963. So I've done a bunch of shooting with all my launchers, and I'm just going to show you, I'll tell you exactly what ammo I was using and stuff like that in these figures. But here we go. Salt supply. I put 20 joules average, but let's just say it's like 19. This will be a little bit lower, but you get the joule average that you're getting with your launcher, and you divide it by 0.3631 because that's the per square inch joule value, basically, like the base raw number. I'm assuming. I think that's what it is. I just basically plugged in all these numbers from video I saw. I'm decent at math and numbers and stuff. So 20 joules divided by 0.3631 equals 55.08 joules per square inch. So that's what the S2 is doing with the normal 12 gram CO2 and probably using alien plays or something, whatever I used in those videos in the past. If I did 19, let's just say I got an average of 19 joules. I'll do that right now on this paper or on my calculator. So 19 divided by 0.3631 equals 52.32 joules per square inch. That's if I had a 19 shot average, or 19 joule average. So it'd be down 3 joules per square inch. TR68 modified, obviously. Let's just say you have it unrestricted and you're just dumping shots out of it. I'm not sure if it's 30 joule average. It could be like 25 joule average because you have the high shots and you have the low shots, but you basically get about 5 shots out of it. Let's just say you have it on a HPA tank or on a 12 gram. Obviously, it's going to be a little bit different, but you take those 5 shots with your 12 gram, get the average joules out of those 5 shots. This could be like 25, and I'll show you that. So we're going to use that same 0.3631 pi r squared number, which is a 68 caliber plug-in. So let's just say your TR68 is getting 30 joules every, average with the 5 shots. You divide 30 by the 0.3631, and you get 82.62 joules per square inch. So that's pretty damn high. Let's just say you got 25 joules instead of 30. So I'll do that on my calculator. Let me clear this out. So I'll do 25 joules divided by 0.3631, 68.85 joules per square inch. So I'll just do, I'll write that down really quick. All right, there you go. 25 joules with the 68 caliber pi r squared value. 68.85 joules per square inch. I mean, if everyone ends up converting this over, this is what you're getting out of these launchers that I've already shot the crap out of. So Saber 68, once I modified it, I'm getting like 19 joules average out of like the 7-shot magazine. So if I plug in the 19 joules divided by 0.3631, which is the pi r squared value of 68 caliber, you get 52.32 joules per square inch. And that's basically what I would get with the S2. You can kind of interchange them if it's cold, if it's hot. You're going to be a little bit higher or lower depending on the temperature and stuff. If yours isn't modified, your Saber 68 is not modified, you'll probably get closer to, let's see here, Alien Play, 79 degrees, 18.87. This was like stock, so it's still pretty close to 19 joules average. If you do the 14-shot average, I'll plug that in. So 14.10. Let's just plug that in right here. 14.1 divided by 0.3631 equals, throw it on the calculator, 14.1 divided by 0.3631, 38.83 joules per square inch. So that's actually lower than the CL, which all this riffraff and randomness is coming from. So burn a CL. So HDP 50, I just shot it the other day. It was pretty warm outside. I was using steel balls. My stock HDP 50 generation 2, I was getting about 18 joule average. I have all the data for that right here. So Gen 2, this is 6 shots. This is my 6-shot average. So it's actually better than 18, but I just plugged in 18 because of this 12-shot average, which is 2 mags, was like 17.79. But I could use these exact numbers. I'm just showing you guys what this can equate to, joules per square inch, with this random stuff that's going on with the CL. So that whole equation up here equaled this number for 50 cal. 50 cal plug-in for this right here is 0.1963. So you get your joules of whatever 50 caliber launcher you have, you divide it by this number, 0.1963, and you'll get your joules per square inch. So let's just say I get 18 joules average with the steel balls on a warm day with my HDP 50 Gen 2, which has the restrictor and the handle. That thing out the box says 13 joules. Obviously, I'm not using super lightweight ammo. So let's just go 18 joule average, even though it's not, it's like 19 or whatever when I shot it on that paper I have, you know, one page behind this. 18 joules divided by 0.1963 equals 91.69 joules per square inch. So that thing's hitting damn hard. HDP 50 cal. If you have the TR50, I have data on that too, like the Gen 2 TR50. Like right here, Gen 2 TR50 using Devastators. This is probably not the greatest to use that equation with because these are not round, but let's just see aluminum balls. I think I was shooting this with the air tank because these look really consistent. So looks like 20 joule average on that with the air tank. I have a bunch of data I could go through. I can show you guys all this stuff. If you've seen my videos, like, you know, I have all this, a lot of stuff written down, and I have like exactly like temperatures and what air sources I'm using and stuff like that. So let's just say you're getting 16 joules average on a TR50. So let's say you modified your TR50 and you're shooting Alien Play aluminum balls out of it, and you get 12 shots and you get that data, and it ends up averaging 16 joules. It could be 13. I'll show you all that stuff. So 16 joules divided by 0.1963. I have it plugged in on my calculator right here. 81.50 joules per square inch. And I'll show you the like if it's 14 joules with the 50 cal launcher. So we'll do that same thing. Let's just say you're getting a 14 joule average with your TR50 with alien plate aluminum balls. 14 divided by 0.1963, which is, you know, the pi r squared value for 50 cal. 14 divided by the pi r squared, and you'll get 71.31. So, like, I'm not knocking Berna or any companies or whoever wants to start, you know, converting this over, but I would just want you guys to know that it's pretty easy to convert. You don't have to be a math whiz. If you have 68 cal and 50 cal stuff, you basically need this number for 68 caliber, and you need this number for 50 caliber, and you get your joules average divided by this number, or divided by this number, and you'll get your joules per square inch. So these launchers, except for the Saber, when it's not modified and I'm using all 14 shot average, all of these were outperforming the CL. And it's easy to do. You just, if you have a chronograph or you've seen these videos from people that shoot these things, let's just say you have the Pistel X68. I'll write that down here really quick. I don't have a Pistel X68, but based on all the data I've seen, let's just say it's a 43 joule average with whatever rounds, Grimberg Joule V3s, AR Tactical Joules, Smashers, you know, whatever the hell you're using. 43 joules divided by 0.3631. Got it right here on my calculator. It's 118.42 joules per square inch. So I'm just going to write that down. J inch squared. So basically, all these are outperforming the CL, probably outperforming the Berna SD. If you want to go by joules, that's totally fine. I don't know how many companies are going to start converting this over to joules per square inch. It is kind of a more accurate number, but you could get into newtons of force per inch and, you know, all this crazy stuff that people are trying to push out. But yeah, simple math, use this number for 68 caliber and get your joule average, divide it by this number, and you'll get your joules per square inch. If you have 50 caliber stuff, get your average joules, or from whatever you see on videos. If you're using the same setup that people are using in videos, say it's 14 or whatever, 14 joules divided by this number for 50 cal, and you'll get 71.31 joules per square inch. So hopefully that helps you guys. This is just kind of just random information that I have, and yeah, I think the math for the LE was like 42 joules per square inch, like 42.1 or something, and the joules per square inch on the Berna CL is like 41.9 joules per square inch. So yeah, this is just what these other launchers are doing comparatively. And yeah, you just got to use these numbers, average joules divided by whatever number, based on whatever caliber you're doing the math for, and you'll get your joules per square inch. So have a good one, and I hope you guys learned something.